This is Mr. Martin. These are video notes for Pre-Calc Advanced. We're in Unit 7 in our book. This corresponds to Section 7.3, so I'll at times refer to it as such. So we're going to start talking about trigonometric identities, and a lot of what we have here you know already. Some of it you don't, and in order to be successful in this portion of the unit, you're going to have to do a lot of practice. You're going to go through some frustration. That's really the only way to get better at these, is to do a lot of problems and work through them. Sometimes you'll work through a problem several times before you finally get it. But if you don't put in the time and the effort, you're really not going to be successful in this unit. So, and then the first step to being successful is knowing your identities. The better you know your identities, the easier you're going to see which ones might apply in a particular problem. So the identities we have here are sometimes called the fundamental identities, and they consist of the reciprocal identities, which again you should know already. We know that sine and cosecant are reciprocal identities. We know that cosine and secant are reciprocal identities, and we know that tangent and cotangent are reciprocal identities. So all of these equalities here are based on our reciprocals. We've also got our Pythagorean identities. Okay, and you have to know these. The easiest one to memorize is this first one: sine squared u plus cosine squared u is equal to 1. And I will show you in another video how we can derive the second and third ones from the first one. So really all you need to do is memorize the first one. Now, in order to understand those two derivations, you need to know your quotient identities. Okay, we know that tangent is the same as sine over cosine, and since the cotangent is the reciprocal of the tangent, it would be cosine over sine. Notice sine over cosine, cosine over sine. Then we have some cofunction identities. These are pretty easy to recognize, because you'll see pi over 2 minus some variable here. In this list here we use u. A lot of times we'll use theta. So make sure you're familiar with these. Keep this sheet handy as you're working through. And then the last ones we have here, I'll just refer to these as the even-odd identities. Okay, and these have to do with the symmetry properties of our trig functions. The sine function is symmetric about the origin. It has 180-degree rotational symmetry, as does the tangent, the cotangent, and the cosecant. And then cosine and secant, cosine and its reciprocal, those are even functions, which means they have symmetry about the y-axis, similar to a parabola. So these are basically our tools, and the identity problems can be thought of a little bit like puzzles, and you have to figure out which of these identities you need to use to solve your puzzle. And I'm going to do the first example in this video, and then each subsequent example I'm going to have as a separate video, so it's easier to go back and refer to those if you need to. So one of the things that we're going to do, a lot of times it'll say simplify, and in this problem I'm giving you a hint. Use the technique of rewriting each trig function in terms of sine and cosine functions. So this is a very useful technique that you'll use all the time. And again, you've got to know your identities in order to be able to do this. So I've got cotangent theta over cosecant theta, and normally I like to work down, and you should get in the habit of working down as well. I know that cotangent, if I use my quotient identity, is equal to the cosine over the sine. So the cotangent is equal to cosine over sine. And I know that the cosecant is 1 over the sine of theta. So I'll highlight that a different color so you can see this cosecant becomes 1 over sine of theta. Alright, and then if we continue from here, when we divide two fractions, we multiply by the reciprocal. So I have cosine theta over sine theta times sine theta over 1. So I'm taking the reciprocal of this bottom fraction. I can see I have a sine in the denominator and a sine in the numerator, so those cancel each other out, and we're just left with cosine theta. So this expression simplifies to cosine theta. Again, it's going to be very important that you're trying a lot of problems. Again, you may need to try a problem several times before you figure it out, and you have to get help when you need it. So go ahead on to the next example, and we'll see you there.